Welcome to this week's video. This week we're going to do two activities. The first one is activity 1.2.1, data visualization. What's the point? The second activity we're going to do is activity 1.2.2, and it's Pirates Are the Problem. Both of these activities are great lessons for us to do this week, and I know it's a little bit more work than what just one was, but each of these individually are smaller than just the ones were in the last couple of weeks. So let's dig into 1.2.1. We're now in a new unit of 1.2. It's about data that's around us, and we're going to find out how do we use that data. So let's start right here. Data visualization. What's the point? We're going to visualize a data set as a graph. We're going to use a spreadsheet program to organize it, filter it, and visualize it. We're going to extract some information from data, and we're going to identify the challenges associated with data processing. So here's some things to think about. Problems. We have all kinds of problems in life, and they can be solved. Questions can be answered, and connections can be made through gathering and analyzing data. Insight and knowledge can be obtained from translating and transforming digitally represented information. Sometimes, though, it is tough to use data when looking at just the numbers. Programs such as spreadsheets can help efficiently organize data to find patterns or acquire information by making tables, diagrams, text, and other visual tools. These tools help you uncover trends, make connections, better visualize problems to solve, and communicate any insights or knowledge gained from data. By the way, when I say spreadsheets, it can be Google Sheets, it can be Excel. There's several different kinds of spreadsheets. My favorite is Excel, but yours might be Google Sheets. In this activity, we will be given a data set to uncover specific information. For instance, the melting point of a pure substance. Every pure substance has a set melting point that is unique. Like chemists, you will find the melting point of a substance that is in a set of data. We're going to pretend we're scientists this week. Okay, to identify the melting point of your unknown substance, you will need to visualize the correlation between time and the substance's temperature as it's heated. A graph can help people visualize the data in a way to see such a correlation. By the way, in case you don't know for sure what correlation is, it's kind of like the relationship between the two. Oh, an association between two or more things. Data analysis may reveal correlations between variables. A correlation found in data does not necessarily indicate that a causal relationship exists. Additional research is needed to understand the exact nature of the relationship. So if you had any questions what that was, that should clear it up. Okay, so let's go back to our regular activity. I don't see how we get out of here. Okay. There we go. There is one substance, one pure substance you probably already know a lot about. Water. We all drink that, use it in cooking, use it in washing our hands, just many, many ways. So we're talking about water. Here's some questions to answer in your notebook. I am just going to copy these. Copy, and I'm going to paste them over to my Word document. At what temperature does water freeze and ice melt? Well, water freezes at 32, I don't know how to get the degrees symbol, degrees Fahrenheit, and ice melts at And I am going to make sure I'm right. Okay, 0 Celsius, 32 Fahrenheit. It's the same for both. I'm thinking boiling, sorry. So it asked, at what temperature does water freeze and ice melt? Freezes at 32 degrees Fahrenheit and ice melts at 30 degrees also. Degrees. I spelled that wrong, didn't I? I digress. That is correct. Okay. So, oops. At what temperature does water boil or condense? I think that's, is it 212 Fahrenheit? Oh, and I better put on here. And 0 Celsius. Is it 212 degrees Fahrenheit? That sounds familiar. Ha, 212 or 100 degrees centigrade. Okay. How about that? Whoops. You don't want to know about the Notre Dame game. Sorry. There we go. At what temperature does water boil or condense? Boil at 212 degrees Fahrenheit and 100 degrees Celsius. Can't type. Okay. What correlation might you uncover if you saw a graph representing water freezing or melting? How far apart both are? How they relate to each other? Will the data somehow indicate to you what its melting point and freezing point is? Yes. I will be able to see each point and their differences. Okay, so you get the idea. You're going to be answering questions in your Word document like you've been doing for each section. And sorry about that. I'm interested in the Notre Dame game. Okay, so during this activity, you're going to see how a graph can be used to identify and support a specific melting or freezing point. So here's the experiment that we're going to do. A lab group wanted to find the freezing point of an unknown substance. They planned out an experiment but had trouble doing the experiment properly. They ran 5 trials, adjusting their lab setup and procedures between each trial. On the 5th trial, they finally had a successful lab. Following is a brief description of their experiment and a visual of what the experiment looked like. The unknown liquid, which was at room temperature around 23 degrees Celsius, was placed in a test tube with a temperature sensor. A second temperature sensor was placed in a container filled with ice water. The test tube containing the unknown liquid was submerged in the ice water. Both sensors began taking readings once the test tube was in the water. Readings were to be taken up to 3 minutes after the liquid had solidified. The lab group ended up running the experiment 5 times, so the spreadsheet contains a lot of unnecessary data that might make it difficult to visualize. The lab group tried to clean up the data and move the trials out of the sequence in which they were done. Before you can do any analysis, you must identify the one usable trial. The data you will see in the spreadsheet is not presented in the order in which the trials were run. They have a little note here for us. Important notes follow about the temperature sensors and the software collecting the data. The temperature sensor records readings twice every second in Celsius by default. So the temperature sensor stops at 300 seconds by default. The software records multiple trials within the same spreadsheet. Each new trial created new columns for the time and each temperature sensor, which all of this makes good sense. You can see it. Room temperature is typically around 23 degrees Celsius. Water freezes at 0. The maximum and minimum temperature values of the unknown substance will probably be in the temperature range of water in its liquid state. In other words, between 0 Celsius and 100 Celsius. Gave us some good information. Now, what do we do with it? During the experiment, some trials were conducted without the proper lab controls, and both good and bad data were collected. You need to determine which set of data reflects their final successful trial. To better understand the data that was collected, you must first get rid of invalid data and then use filters, sorts, and visualizations to make meaning from the numerical data. Read the data collection story of the 5 trials before opening the spreadsheet. So the first thing we say is trial 1. The software setup was incorrect. The lab group only set the sensor up to take readings for 50 seconds. The data collection stopped before the liquid solidified. So that's invalid. We can't even use trial 1. Trial 2. The sensor that recorded the temperature of the unknown substance was accidentally unplugged. The lab group plugged it back in but was not sure how long it had been unplugged. Trial 3. The sensor for the unknown substance was never plugged in, so it didn't get any readings. Trial 3 you can just throw out. Trial 4. The lab group removed the test tube from the ice bath to check if ice was forming. In doing so, the temperature began to rise. They then put the test tube back in the ice bath, but the sensor stopped recording data before the substance froze. That's unfortunate. It shows parameters of what it did, and somewhere in the middle, it's going to show it went down a little bit, or went up a little bit, but it probably was closer to it. In trial 5, the unknown substance was successfully recorded as it froze, so no additional trials were conducted. Trial 5 is really the only one that would really be valid. 2, you could kind of see some. In trial 4, you could kind of see some of the data heading that way, but 5 was the only one that was correct. So, here's some data challenges. Regardless of the size of data, some common challenges with data are as follows: needing to clean up data, having incomplete data, having invalid data, and needing to combine data sources. All of those are real data challenges. You can read through this career connection. It's a really nice little thing about our software engineer, Jade Sissel. Now, the nuts and bolts. We're looking at the spreadsheet data. Sign into your Google account or create a Google account according to your teacher's instructions. Just sign in using your eSACS information and have Google up. Open the Data Unknown Substance spreadsheet containing the experimental data. So when you click on this, it should open if you're in Google. So you can see it has all kinds of information. Here's data set 1, data set 2, data set 3, data set 4, and data set 5. We have all kinds of good stuff here. Because this spreadsheet is protected, you will need to make a copy of it to your own account so that you can manipulate it. From the menu ribbon, select File, make a copy, update the file name so you will recognize it as your file.